So here you see the interior of the Earth, and we're going to see that actually the interior of the other planets don't necessarily have this convection I'm going to describe. But the Earth is still very, very hot in its center. And actually then kind of related to that, the liquid mantle, this is the mantle part, remember, and the part closest to the core is liquid. And so it gets hot down here. And kind of like a lava lamp, the light in a lava lamp basically heats up the liquid at the bottom, and then that liquid expands and it becomes less dense than the liquid around it, so it wants to rise, just kind of like hot air gets warm air expands and rises in your house. So that creates the beginning of what we call a convection cell. So hot material will rise, it's going up. Actually, we see two convection cells. As it rises, gets away from the hot core, it will cool down, okay? And then you can actually see that it will kind of ride along the side, and eventually it will become so cool that it'll be dense then when it's cooler than its surroundings, and it won't fall down towards the core, so that it kind of continues down here. This one cools down, and then it sinks right here. Okay, so can you see where we basically have two convection cells right there, rising and then kind of falling down together? And I think this is cool. So we have these blobs of liquid mantle, circulating in these cells, but it takes 100 million years for it to complete one cycle. And that's kind of cool. So that's one way that the Earth is actually getting cooler, that we're cooling down our core. There are two other ways that the Earth itself is cooling down. So, of course, this is convection. This right here, I don't know if you can kind of see it, is what we call conduction. And sometimes I call conduction molecule to molecule. Basically, the reason I say molecule to molecule is stuff needs to touch, needs to bump in order to kind of transfer the heat from one particle to another particle, whether it's a molecule or not. Conduction is well described if you are boiling water on a stove, and it's been on the stove for a while, and you go to take it by the handle, and it's quite possible that that handle is hot. The handle is not hot because it's been next to the heating element. The handle is hot because energy has conducted up through the handle. So the Earth is cooling down that way. And then these little squiggles here are, I'll go ahead and say IR, because remember we said that one form of electromagnetic radiation is infrared. And I'm hoping that one form of infrared you're going to kind of think of as heat. So this radiative energy, is kind of the last leg of the energy of the Earth cooling down. So if we look at them side by side again, kind of line them up from largest to smallest so we can kind of look at them again. One of the things, it's definitely a player, is with regard to cooling. The larger the size, the longer it's going to take to cool off. Assuming that all of these objects, the moon and the 4 planets, assuming that these terrestrial planets had similar heats to begin with, the large ones are going to cool off more slowly. Oh, that's what I meant to say. The large ones cool off more slowly. And it's kind of like, and this happened recently in our house, it's when you buy one of those Papa Murphy's pizza, and it's family size, and it's hot out of the oven. You're like, oh, I love it hot. Okay, so that's awesome. That is gonna hold its heat longer than if you pull one piece and put it on a paper plate. That one is gonna cool down faster. So the point here is that the Mercury and the Moon really cool down fast. Mars cooled down pretty fast. Okay, but as they cooled down, the liquid mantle was no longer liquid. Planetary differentiation created their cores and all that, but eventually they cooled down to the point of solidifying. So when we talk about a dead planet, we mean it doesn't have volcanoes, it doesn't have earthquakes, it doesn't have what you've probably learned as plate tectonics. It doesn't have tectonics. Okay, so the Moon and Mercury are dead. Of course, the Earth is still ooey gooey in the center. We just saw those convection cells on a previous slide. And Venus, we think, is ooey gooey in the center. And Mars, the jury is out. okay, as far as I could tell, with regard to having some sort of fluid in associated with this mantle.